didn't fully grasp the significance of the OE-cat. Can you?
Awesome. Okay.
The
That's
significance,
the next slide.
the significance of the opcat.
Can you go to the
What's the
next
significance
slide?
of this opcat?
Yeah. So opcat.
Opcat.
Yeah. First, raise your hand. How many heard about this? Okay, raise your hand.
I heard about it on Twitter, on X.
You don't have to know what it
Yeah.
is. You just heard about it. Anybody heard about it? Okay. 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 What it is? What is it? In your term, in your language, what is opcat?
Concatenate to.
Yeah. I mean, functionally, it's very simple. So basically, let's say you have hello, you have word, you concatenate them, you have hello word. Okay. It's very simple, logically, conceptually, very easy. But what's all the fuss about it? Okay. Why is people making a big deal out of it in Bitcoin today? As I said earlier, it was there when Satoshi first released version 0.1. It was there, and later on, he disabled it for security reasons. Okay. And then people are talking about, hey, bring it back. Why this is a big deal? Because you only change a few lines of code, but then it enables you. It's a very simple yet very powerful primitive, right? It's like your calculator, right? Maybe first now you can only do addition, but what if you want to do, let's say, exponent, or once you add this opcode, it enables you to do many other things. It's like you have hundreds, if not thousands, of new use cases. That's previously impossible. But once you add this, for example, we have something we can demo. You can even run some almost unbounded loops, which in a sense make it Turing complete. So it's a very small change, but it will bring a lot of so-called smart contractability onto Bitcoin. So that's a short story. Okay. So which applications is going to we're going to introduce? I have a few examples, and then maybe at the end you guys have. The idea is to, hey, this is only the tip of the iceberg. Okay, I can come up with these use cases, but you guys can come up with hundreds, if not thousands, right? It's like Ethereum. Okay, I just give you this tool and all these high-level tools and APIs. Once you have opcat, you pretty much, I think you can pretty much whatever you can build on Ethereum, you can build it natively, layer 1 on Bitcoin. Okay, once you have this. So think about today, right? I mean, you can build something on layer 1 Bitcoin today, but it's very limited. I cannot think of maybe some hash lock, maybe some lightning, some channels, multi-sig, but not much, right? For example, you cannot build AMM or it's just an automatic market maker, right? One of the most popular application, DeFi application on Ethereum-based chains. You cannot build, let's say, trustless bridge.
What about Athena, and Bank? I mean, is that a layer 1? Because they build,
Yeah, that's I call it layer 2 because that's
a layer 2.
Using
Runes, yeah.
Token protocol.
Runes is not layer 1.
No, Rune is like it is its own indexer, so it's not enforced by miners. When I say layer 1, in my terminology, when I say layer 1, it's reinforced by the miners.
So Runes is not layer 1.
It's not. It's not because the miners don't know about runes. It doesn't know. It just run the inputs, outputs. It doesn't know what is inside. Versus Ethereum world. In Ethereum world, the miners know that ERC tokens, ERC20 tokens, because all the tokens, they are enforced by the miners. That's the difference. Okay. So once you have CAT, I would say 100% of all the apps you can build on Ethereum or Solana, you can do it on Bitcoin layer 1. I think it's very close to 100%. Okay. So right now it's almost like 0%. So you add this small thing, very small thing, seemingly very insignificant, but then you can almost boost the capability by it's not even 10,000 times. Okay. So that's why. Hey,
will it affect the transaction fees?
I mean, it depends on how you use it. Basically, the transaction fee is like depends on the size of the transaction, right? So if you have an OpCat, if you have built a bigger script, bigger transaction, yeah, then you pay more fees. Yes, you can. Yeah, you can. But it all depends how you use this. Right. Okay. So keep going. So I think one of the first example use cases people always talk about OpCat is so-called this covenant. Okay. Again, raise your hand. Covenant. How many heard about this term?
No.
You don't have to know what it is. Just heard about this term.
Covenants.
Okay. Covenant. Yeah, it's a fancy word, but it's also very simple, right? So today, Alice Bob, right? If Alice sends some bitcoins to Bob, it's Bob's. Bob can spend it in whatever way he wants, right? Alice cannot dictate or cannot control anymore. Okay. So covenant is a way to say, hey, after Alice sends Bob, Bob can only spend the Bitcoin in certain ways. Okay, you are incumbent, you are enforced, you are limit, constrained how the recipient can spend the coins. Okay, so for example, right, if I'm like, let's say if I'm a parent, I want to give some allowance to my kid. You know, I can, if I send him just the raw Bitcoins, you know, he can buy whatever he wants. I don't know, maybe alcohol, or, you know, whatever he wants. But if I have a covenant, I can say, hey, you can only use it in this number of stores, have this address. You can only buy, I don't know, candy or, you know, GameStop or whatever. You know, you can limit how the recipient you can enforce, constrain how the recipient can spend the coins. Okay. So I mean, this is a very powerful primitive. It may look not that impressive, but built on covenant, you can build a lot of other primitives on top of it. Okay. So basically, it lets you to, you know, you have the transaction before, we have the transaction A, and then transaction B spend transaction A, right? So once you have the covenant, you can, you know, from the contract, you know, previously we can think about the contract only do like a math function, right? You can do square, and maybe you can do add two numbers, you can do hash, but that's it, right? But then if you have covenant, the contract can access the transaction itself. So that's how it, you know, adds a constraint. Right? For example, you can say, hey, this transaction, you know, the output can only be 3 outputs. Or you can say, hey, this size cannot exceed, you know, I don't know, 500 VBytes. Or you can say, hey, we can only go to, after Bob received it, can only go to, you know, Charlie's address. Right? You can, basically covenant can let you, in the contract, you can access the spending transaction. Then once you can access it, people call it inspection, then you can enforce all the different conditions on the spending transaction. Okay, so that's a short summary. So just to give you a sense, what sCrypt, why you want prefer to use sCrypt. So on the left side, you know, this is the Bitcoin script version, how you do a covenant. You know, I don't know about you guys, but it looks like a very esoteric, okay, to me, okay. It's not anything, you know, any kind of so-called Web 2 developers or any kind of, even Web 3 developers, they want to even come from this land. You are pretty much writing machine code here. This is Bitcoin script way. Versus on the right, you can scroll up a little bit. You know, it should look familiar if you have any kind of like JavaScript or any kind of object-oriented programming experience, right? You have functions, you have operators, you know, you have assertion, you have variables, right? You just call different functions and you know, do them together. Okay, so it's a much simpler way, faster way for you to code anything non-trivial. Okay, covenant, good. Good. Okay, let's go to the second one. This is another one. Example. Merkle trees. Anybody heard about Merkle trees? Good. Merkle trees. I think if you're Web 3, probably you have most likely you have heard about this. You know, data structure. You know, you just have a leaf node, a list of leaves. It basically is a simple way to check set membership. Okay, so you have a gigantic set. Usually how you check if some item is in it, you have to go through each one, right? But then using this data structure, it's very simple but also elegant. You can hash them. You have the, you hash, you concatenate until you get to the root with a single root. So this pretty much represents the whole set. It's a commitment to the whole set. So if you can, then you can check whether some item is in this, instead of big O(n) complexity, you can check in big log (n), which is the depth of the height of the tree. Okay, so this is the very, you see here, you see this data structure everywhere. For example, mining, right? So you have a big block, you have Bitcoin blocks. You mine a new block. They have the block header. Block header has a, have the hash of all the transactions in that block. You have all the transactions here. You hash them. You get the root, and this root is going into the, when the mine is mined, it's going to end up in the block header. Okay, it's just, it's a block header. Or you can do, if you have let's say so-called Merkle proof. If you want to prove some transactions in some block, you can use this simplified payment verification in the white paper. It also mentions a Merkle proof. Okay. So as you said, as you can easily see, right? So every time you go up one level, you hash, and then what do? You cat. Okay. So that's why this is a very, very popular, useful primitive, but only if you have cat. Okay. So then you can use it all many different ways. It shows up everywhere. Okay. So if you see on the left, can you drag to the left? Okay. This is how you code it if you're using raw Bitcoin script. Okay. So the short story is this is the root of the tree, and then you are doing a lot of stack operations actually, and arithmetic. You are doing hash. You are doing a check if you have reached the end of the tree. You're doing a DApps. You substrate by one. Yeah, it basically is almost unreadable. Okay, even to me, I worked with Bitcoin script many years, but it's not very readable at all. Imagine now you have to use this to code your, your tic-tac-toe, or your side chain, or your bridge, or whatnot, right? It's very, very complicated. It's almost impossible. Okay. Versus on the right, you have the equivalent sCrypt version. Okay, readable now. Everybody can hear, right? See, it's just function. It's a loop. It's like basic stuff. I think now they teach in primary school, so I'm pretty sure everybody here can easily pick this up. This is something on the left. You probably need some kind of PhD or something to be able to code it. Okay. Right. So it drastically lowers the barrier of entry from some primary school stuff. PhD level to primary school. Okay. That's a short way. That's the simple way to look at this. Okay. So this will enable, for example, people always talk about side chains, right? It's just another blockchain that somehow is packed, right? But the issue is always, right now you need some kind of like a centralized entity, because if you have some, let's say, you are bridging some BTC to some other chain, you have a wrap token there, right?
Yes.
But then on the one, when you peg in, it's easy, right? Because that side chain is programmable. Yeah, you can verify, hey, some BTC is actually sent to this address or burned or whatever, or staked or locked. You can check on the side chain because there's a smart contract, but not vice versa. When you peg out,
Yes,
on the BTC world, right?
It's very hard.
Because if you don't have OCAD, you cannot verify, hey, is this wrap token burned, or is it sent to this good address? Is it staked? You don't know. Basically, BTC, you cannot know the state of other blockchains, right?
Actually, if you use a hash time block contract, it can. But it's still,
But you cannot do.
You can break.
You can pack one
it,
direction, but you cannot come back.
You can come back, but we also need another decentralized off-chain.
But I mean,
protocol.
you cannot in a Bitcoin script. You cannot come back.
You can, because I gave a time block, and during the time block, and it's a little bit different.
Yeah,
Yes, a little
you are
bit
not
different.
talking. Yeah, it's a different. Basically, you may enable to you to build so-called, trustless
Yes.
two-way path bridge. Okay, that's just one of many thousand, if not millions, of applications that's now doable because this is simple opcat change. Okay. The third one. Okay. So this is also very cool. I think people talk about this for a long, long time. So how many people here have Bitcoin? Okay. Okay. I'm not going to rob you later, but yeah, if you have it, I mean, one of the worst concern you have is like you wake up one day, you check your Bitcoin, it's gone. Okay. I mean, that happened to me. I don't know about you guys, but it did actually happen to me. Okay, it's a small amount, so don't worry. But it's not good, right? That's one of the biggest problems for newbies, for average Joe. That's one of the biggest issues because if you have money in the bank, hey, if somebody steal your the credit card or whatever, and spend it to buy some gas or whatever, you can always call the bank and then get the refund, right? Or you can call Chase to get the password and then re-access your bank account, right? Your money is safe. Versus Bitcoin is different. You put it in a wallet, you wake up, it's gone. Who do you call? You call Coinbase? You call Binance? It's not going to work. It doesn't work like that, right? Not your keys, not your coins, okay? But it comes with a risk. It can be stolen. What if you have a so-called vault, right? I mean, the idea is, hey, every time you want to move Bitcoin out of this type of wallet, you have to wait. There's a cooling period. You have to wait 24 hours. It's like some exchanges, right? You go there, you say, hey, I want to initiate withdrawal. You may say, hey, you just log in or you just create this account. Maybe you have to wait 24 or 48 hours. Okay, it's much more secure because then you imagine somebody you have some coins, Bitcoin locked in a vault, and then somebody somehow steal your private key. He wants to withdraw the money out of it, and then he has to wait 24 hours. And within that, as soon as he initiate the first transfer transaction, you get a trigger, you get a alert, right? Say on your phone, hey, is this you, right? It's like you access some online banking. Hey, is this you, right? Maybe you are traveling to Europe or whatever, and then you get a notification, hey, is this you? If not, hey, call the bank, right? So this is almost like a banking, you're almost like, hey, you have a protected banking account here. If somebody steal your private key and try to take the money out, you get a trigger alert. Hey, is this you? If not, you have a backup key. Okay, so you have the concept here. You have two keys. One is like a hotkey, is in a wallet or I don't know, browser like extension wallet or mobile phone. But also you have a code key. Maybe you need to write the mnemonics on your paper or lock up a box in your bank account or safe. It's somewhere offline. It's never online. So the hackers it's like hardware wallet, right there. So then you can use this code key to override this unique withdrawal request, and then take the money back to some other address you control. Okay. So this is make it much more secure and much more difficult for attacker to steal your coins. Right? It's almost like a banking feature. This vault. You have a cooling period, and then if you notice, hey, this is not you, you can use your code key to override it. Okay. Is this clear? The vault. So this, if I can put my bitcoins in a vault, I will sleep much better, to be honest. Okay. Because if somebody steal, the problem with Bitcoin is that if somebody has already stolen your key, you don't know. And once you find out, it's already too late. Okay, so this gives you some kind of advanced warning. Hey, maybe it's also configurable, right? So if you want to set it 24 hours or 48 hours, you can even put a multi-sig there. Hey, when you withdraw, you need 2 or 3, or when you use a hardware wallet, you only need this code wallet. You can. It's very configurable. Basic idea is you have a cooling off period. You have to unvault, and then within this period, if you notice your key has been stolen, you have a way to take your coins back. Okay. So this also, I mean, you cannot do it today, but once you add this small opcat, you can easily do it. Okay. I mean, easily. I mean, if you use sCrypt, okay, because it's just not many lines of code, like in TypeScript. This is what it looks like. I mean, all of this, by the way, is on our blog on Medium, and with all the working code. You can actually test it on, some kind of testnet on Bitcoin called Signet. So basically, we have the full working code. You don't have to trust me again. Don't trust. Also, always verify. You can go there and pick up code, and you can verify it yourself. Again, this is the equivalent version if you're writing Bitcoin script. Okay, it's not beautiful. Okay, I'm telling you. I mean, you have a lot of opcasts and some other stack opcodes, but this I only show you maybe like 50%. I mean, it's like I cannot even write on the whole string. It's very, very long, and also there's no way to debug it. It's almost impossible to debug it, right? Versus if you use TypeScript. Okay, how many people here use VS Code? Okay, VS Code, or any kind of ID. You can, because it's just TypeScript. You can use you can use npm. You can use VS Code, Atom, Vim. You can use your favorite JavaScript testing frameworks. You can use it. Also, my favorite feature, you can use the TypeScript debugger. Hey, you can easily, there's something wrong, you create a breakpoint there, you step through there, and you look at the variables. It's like the programming experience is the same as Web2. Okay, so you don't have to. For you, it's just a new library. You can come here, you use all your normal standard Web2, development workflow to deploy, to develop, to debug, to test, to deploy, to publish. Everything is the same. It's just another library. Okay, that's the benefit of using sCrypt framework. So last one, I think this is one of my favorite. Previously we talked about covenant, right? Yes. So it's like another advanced version of covenant. We usually call it a recursive covenant. So previously we talked about the covenant, right? Meaning you can only control one step, right? So Alice sends to Bob. You can control how Bob spends it, but that's it. After Bob send this thing to Charlie, then Charlie is free again, right? So basically, the recursive covenant basically says, hey, I want to have these coins. I put this coin in some smart contract. This thing is recursively enforced. So not only when Charlie receives it, Charlie also has to, is also enforced by the same contract again. Even Charlie says to Dave to, whoever, everybody that received the coins later on, he can be constrained by the same contract. Okay, so this is very powerful because it can enable, for example, you can maintain state. One of the things. People always talk, hey, in Bitcoin UTXO, you cannot maintain state because UTXO, right, by definition, you spend it, it's gone, right? You cannot, spend half it, or you cannot. It's a whole. It's like you have this concept of change, right? You go to a gas station. You have two bills. One is $5, then another $10, and then if you want to buy something worth $13, you cannot. You don't split. You don't split your cash, right? You just have to give it whole, and then it has to come back in the form of change, right? It's the same thing here. Once you spend, it's gone. And one of the biggest use cases for recursive is, hey, you can simulate the state in the UTXO. How does it do it? So basically, I have an example here. Let's sit down. So for example, here I have a very simple. It's the simplest state. So you start with 0. Every time you call this contract, you have to increment by 1. So this is a different chain of transaction. This is 0, this is 1, this is 2, and every time you have to increment exactly by 1. That's the only way you can spend it. That's the simplest way you can maintain a state machine. So that goes back to my original claim. Once you have an OCAD, you can almost do anything you can think of in an EVM land, because Ethereum, right, it's just a gigantic state machine. you have different account address, maps to the contract state, and then every time you call a transaction, you just go to from one state to a new state. That's it. So once you can simulate this in the Bitcoin UTXO model, you can pretty much do. I think maybe there's some very edge cases, but I'm very confident you can do most of the stuff. If not all the stuff, you can do it in Ethereum world. Okay. So that's one way to do it. I mean, you can go to a lot of other use cases. This is just one way to, hey, you can do it now, you can do stake now. Okay. Any question? I think this is just 4 of the use cases. Each one is very big. I would love to you guys go back and check out this, build this. Okay. Because you will be the first to the market, because OpCat is not on mainnet yet, but it's on the Signet. You can build it today. When it turns on mainnet, hopefully soon, then you are the first. You are ready to go. Okay. You don't have to wait. And all our tools are open source, and we have examples, documentations. You can go there and check it out. Okay.
I've been following your blogs for a long time, so it's
Oh,
really nice to see you present in person.
Okay.
Like
Cool.
the script blog. I was curious though, like, are there any like applications you're seeing right now of like anything on mainnet that people are building or using, or you like limited until OpCat sort of goes live?
Mainnet, as you are aware, there's no on the BTC land. There's no OpCat. Yeah. Okay. So, but people are building on Signet. You can do it on Signet today. Okay. So, and when we first started, we work on other Bitcoin forks, namely BCH and BSV, because they have re-enabled all, not only OpCat, but all the other opcodes. So people have been using us for quite a few years. I think they built something, a lot of things I think are very impressive. For example, they built an AMM natively on BSV using sCrypt. It's just like a Uniswap or SushiSwap. You just run it on chain, TS-Swap, called TS-Swap. And then people build, what else? Hodl locker basically is to, you are staking, but you are lock up coins. And because you can verify, everybody can verify its own chain. So you are not saying, hey, I'm a team, I issue tokens on Bitcoin, and then, hey, this is my, the schedule I can unlock. You don't have to trust the team, right? Because it's all programming there. And also you have different ways to control tokens, ordinals. For example, people use this to build so-called ordinal marketplace on chain. So basically, today, if you're on BTC, you can do a PSP-based marketplace. But it's kind of awkward. You have to be, hey, but what if I'm like Ethereum? I can just submit the transaction, listing my ordinals. Whoever wants to buy it has to send this address, this amount of Bitcoin. I think people can do that, BTC ordinals, okay. And what else? And you can also control how you issue your tokens, right? Bitcoin has this token called either BRC20 or runes. Sorry, BRC20. You have this open mint concept, right? Because whoever can send the transactions, you can get a mint. But then you can also. But there, some people may say, hey, it's not even fair that way. What if you can say, hey, you have to do some kind of like a mini proof work. Hey, instead of hash like a main chain, you have find 100 leading zeros. You may find 10. Right? Every 10, you can get this amount of coins using proof of work. Or you can say, hey, you have to lock up coins to lock up your BTC. You can basically, it turns the whole Bitcoin programmable. Because previously it's almost impossible to program. But right now, once you have this opcode, if it's ever activated on mainnet, but today people on other blockchains have built all kinds of, I think hundreds of other examples. But you can check out these examples, but also you can also port them. It's a low-hanging fruit to port these good ideas, or even get some Ethereum ideas and start building on it today on Signet. I think that's one of the biggest opportunities. I think the biggest, I'm not saying it, because I'm myself, and we're building some stealth project with leverage OpCat, which is going to be very, very cool. And which people think is previously impossible before. Okay. Anything you want to build
I mean,
already in mind?
like we're working on a Bitcoin project, but I actually had a follow having AMMs and like on like Bitcoin, the block time is very very long, right? One like MEV becomes like a big problem, and then everyone's just trying to front run everything all the time. How that work?
Yeah, I think that's issues because of the long block time. But there are ways. I think if you have to, it's kind of like Ethereum. I mean, there are ways you can design your protocol, your apps to be, I wouldn't say eliminated, but alleviated that. Because in Bitcoin system, it's much more resistant. Let me check. Okay, this is our experience. So previously we have this AMM on Bitcoin SV. We find it's much more resistant because in a Bitcoin UTXO model, you are chaining the transactions, right? You cannot easily remove or reorder. You may censor, right? But I don't think you can. For a lot of apps, you cannot reorder. For example, right? Let's say you want to sandwich attack. How do you? It's a chain of transactions. It's all binded by the TXID, right? So I don't think you can. Yeah, it can be an issue, but what I'm saying is, it's less of an issue. It's more resistant to MEV or MVO. Some people call it MEVO. It's much more resistant on Bitcoin because of the UTXO chain transaction. It can, yeah, you have to take this into account if you want to, let's say, reduce the risk or reduce the attack service. Yeah. But if you have issues, we all have developer channels, Telegram, Slack, people are talking about all kinds of things. If you have issues, yeah, definitely, go. Can you go? Yeah, definitely go and just go to the last one. That's fine. Yeah, definitely go to join our, channels and, you can look at our GitHub, Telegram. We can always, because this, to be honest, is very new, and that's also the Wild West. There's always, there's always tons of opportunity. For example, how to design in the UTXO model to be MEV resistant. I think, yeah, if you have concrete examples, we can talk about. What I'm saying is, you have the MEV on other blockchains, right? So the apps are still running, and here, because it's inherently more difficult to have MEV in the UTXO TXID model. So I think you can still make it work. I mean, of course, it's a long blockchain time of 10 minutes. For example, one way we also have the same problem actually. So what we found is, you can chain, do you understand the concept? Have you heard about the non-standard transactions? Standard versus non-standard transactions? So basically in a normal transaction, you broadcast it, all your peers are going to relay it to the miners, and the miner is going to take it, right? But then there's some checks in the default Bitcoin node, basically check, hey, let's say if the fee rate is too low, right? For example, you may have some very complex script in it. By default, the node is going to drop it, to reject it, okay? Will not deliver to the miner, so you will not go to the miners to be mined. But that's a way to submit it. It is still legit transactions, but it just will not be it will not be accepted by and relayed by your peers. So what the people can do is they go directly to the miners. So they submit to the miners because miners want to get more revenues. So the miners will take it. For example, the famous 4 megabytes, the inscriptions, right? Because if you just broadcast this transaction in a peer-to-peer way, it will be dropped. So you have to contact some miners. So that's one way to avoid, I think, or at least reduce. So if that's your concern, maybe talk directly to some miner. You can directly send it there, and then it will just be mined. If you trust a miner, because only that miner knows it, right? It's just one way. I think there are many different ways to make it more resistant. Yeah.
Yeah, I think right now one of the marketplaces like ask you for like 4 different fee rates, and then if somebody tries to front run that buy, they just post it again, and then they post it again. It's not bulletproof.
Yeah, it's
whatever.
not. That's not. You can always. Yeah, you can. Yeah, the ones. Yeah, I mean, Opcat is my #1 wish, but if I have another wish, we somehow get rid of the replace by fee. Okay, that's my biggest wish. And then let's make it much similar to build all kinds of apps. You can even do instant payment, because today you can do not go to a coffee shop, buy your coffee with Bitcoin.
Yes.
Forget about the fee, because if you buy it and you go out and you double spend it to your own address, you get a free coffee, right? Because of the replace by fee. Imagine, that's just another feature I think I wish we don't have it, but it's just something we have to, when we design our app, we have to take it into account. By the way, BCH and BSV and some other UTXO blockchain, they don't have this issue because they don't allow replace by fee. Because replace by fee, as you said, it's always messy. Because you send a transaction, somebody, because this thing is always publicly visible on some mempool before it gets mined. Somebody else, if he wants, he can always play this game of beat you up and then pay a bigger fee and get it mined. But then you can always counter him. Yeah, it's like a UI nightmare. Yeah, but yeah. So short story, it can exist, but I think it's going to be less prevalent than on Ethereum or other blockchains. And those blockchains, they still have some apps that suffer the same issue. They are still running. So I think it's just you just have to, when you design the app, you have just to take this into account and minimize the impact to the end user. For example, right, another thing is like a sequencer, right? I mean, ideally, you should wait for the settlement transaction to be mined, right? But a lot of times when you send on layer 2, if you trust the sequencer, right, it's not going to mess up. He just give you 2 seconds, hey, this is accepted, you just forget about it from a user's perspective. So there are some improvement ideas you can do at the UI level to make the user experience not directly affected negatively by the long block time or RBF. But yeah, there's a lot of design decisions you have to make to make the users feel less pain. Okay. Does that make sense? Cool. Yeah, but good question. Anything else? Okay. Okay, that's the end. If there's no questions, I think we can always talk offline. Okay.
Yeah, thanks a lot.
Okay.
Thank you, Xiaowei.
Thanks a lot.